I think last lecture I started with the question, reduce the following matrices to the normal form and find its rank, right now? Reduce the following matrices, the following matrices to normal form. Now second onwards, you have to write simultaneously to normal form and बघा अजून जॉइन होते त्या म्हणजे हा डिस्टर्ब करतो and find its rank. Now I want to show how the possibility is there. Now see, who is it? Aditya Patil. I have to switch the window na, and find its rank. Find its rank. So already one example I have completed. Suppose the second example, I will write the statement. The matrix is given with first row, the elements are 2, 3, -1 and -1. Number of columns, there are 4 columns, 1, 2, 3, 4. Second row, 1, -1, -2, -4. Third, 3, 1, 3, -2. Fourth row, 6, 3, 0, -7. Okay. So this is the given matrix. So whatever we have seen. So can anyone recall what is the normal form? What you understood? What is meant by the normal form? Yeah. Anyone can unmute and well. Yes, Sankalp.
It is the elementary transformation of rows and columns to 1 and zeros.
Okay. Suppose the matrix A is given. Okay. To explain, I will use A is a matrix of order m by n. Now you have to apply an elementary transformation on matrix A. So that elementary transformation includes row as well as column transformation. And there is a standard procedure how to apply that elementary transformation. And what are the elementary transformation, that also I was explained. Now when you apply elementary transformation, you will get a new matrix which is equivalent to A. Suppose this is a B. So where A is equivalent to B such that in this matrix, the diagonal elements are either 1 or 0. Okay, for example, I am writing. And all other non-diagonal elements, these must be 0. And after getting all the diagonal elements, you have to arrange that matrix in such a way that, so first diagonal entries are 1 followed by 0. 1, 1, 1, 1, 1, 0, 0, 0, 0 like that. Okay. So this is called as a normal form. This is called as a normal form of a matrix. Normal form. And what is the rank? You have to count number of 1 or unit matrix. There is a block, na? This is suppose a block of the matrix. This is a block of the matrix. This is a unit matrix of order R. Then R is a rank of the matrix. Okay. So first step, I will call the given matrix as A. Suppose I will write given matrix as it is. A is equal to first row 2, 3, -1, -1. Second row 1, -1, -2, -4. So what I am doing in the first step, I am calling only the matrix as A. 3, 1, 3, -2, 6, 3, 0, and -7. So this is a matrix of order. Yes, what is the order? 4 by 4, not necessary to write. So after writing the matrix, your first step is fix the diagonal entry of the matrix. Means A11, A22, A33. This is the diagonal entry. So after the diagonal entry, so you have to convert this A11 element to 1 by applying any elementary transformation. Can anyone guess what will be the elementary transformation?
Interchange row R2 and R1.
Correct. One can tell, we can interchange R1 and R2. That also correct. Here for your understanding, I will write interchanging of R1 and R2, or one may tell R1 minus R2, that also fine, na? 2 minus 1, you will get 1. So that's why the answer is not unique, depending on your elementary transformation or what kind of transformations you are applying. Accordingly, you will get elements, but rank should be the same. Suppose here I will apply interchange. Suppose by interchanging R1 and R2, now you will get a new equivalent matrix. New equivalent matrix. Now, when you are writing the new matrix, depending on your transformation, you have to represent that matrix. Here, I am applying row transformation, and the row transformation says that R1 and R2 you have to interchange. So when I am applying row transformation, I will represent, or I will write a matrix row wise. When I will apply a column transformation, I will write a matrix column wise. So in this case, that second becomes first row. 1, -1, -2, -4, 2, 3, -1, -1. Remaining 2 row, no change. 3, 1, 3, -2, 6, 3, 0, 7. Okay. If it is easily possible, try to obtain this element as a 1. Now, again, this is a diagonal entry. This is your diagonal entry. After getting the element A11 as a 1, so while doing this, you have to avoid fractions. Yes, Prerna.
सर वो -7 है.
Okay, last element is -7. Thank you. Okay, while writing, if I make mistake, then you tell me. Now, what I am explaining. Okay, after getting the element A11 to 1, now the next one is you have to reduce the element which are below to A11. These elements I am circling. These elements you have to reduce to 0 by using this element, means R1. So I will take the name Pranav Vaidya. So corresponding to 2, what is the transformation? This 2 I have to reduce to 0. Pranay, na? Immediately, because we have to cover examples. Okay, Omkar.
Sir,
Omkar, if you are using hand raise option, it's okay, fine.
2 R1 minus R2, 3 R1 minus R3, and 6 R1 minus R3.
Okay, little bit you have to change. What I have to change? R2.
2 R1 minus R2.
Okay, Pranav says no, my 2 R1, no. R2 I will change as multiply first row by R1. Okay, that 2 becomes, na? And that resultant you have to subtract from R2. In the same manner, R3 minus 3R1, is it right? R4 minus 6R1. Now in this case, the R1 is the pivot row or the key row. So that row you have to use to reduce the element as a 0. Then you will get a new equivalent matrix. What this transformation says, change for second, third, and fourth row. First row, no change. That means 1, -1, -2, -4. This no change. Now for second transformation, you have to multiply first row by 2 and their subtraction. Now directly I will write it. Is okay, na? 2 minus 2. Tell me. 3 minus plus 2. Unmute and tell directly.
Five.
Yes. -1 minus plus 4.
3.
3.
Yes. -1 minus plus 8.
7.
7.
Next you have to multiply by 3 and their subtraction. Now, obviously, 3 minus 3 is 0. Now, tell me, 1 minus minus.
4.
Yes. 3 minus minus 6.
9.
Minus 2 plus 12. 10. Pradnya, Survey. Okay. 10, correct? Verify the calculations.
10.
Okay. For the last one, you have to multiply by 6 and their subtraction. Now, 6 minus 6. 0, obviously. 3 minus minus plus 6.
9.
0 minus minus 12. Next one.
17.
0, 9, 12, 17. It's
17.
17.
correct. So this is a new equivalent matrix. This is your diagonal entry. Okay. You have to follow this standard process only. Now, after getting the elements below to A110, though your pivot element is this one. After getting the elements which are below to A11 as a 0, you have to reduce the elements which are right side to A11, these elements to 0 by using column transformation. So while using column transformation, you have to use the C1 first column as a pivot or the key column. Now, transformation, tell me anyone.
C2 can be changed to C2 plus C1.
C2
Right.
plus C1.
Next, C3.
C3 plus 2C1.
Yes. Okay, your writing fashion may be different. C4 plus 4 times C1. So what this indicates? Yes. Most of the students, they are writing in the chat box. It's fine. So this shows that change in the second column, third column, fourth column. Now you are applying a column transformation. You will get a new matrix which is equivalent to first column. Shivam, Jaju, admit. Okay. So first column, no change because I am applying a column transformation. You have to write the matrix column wise. 1, 0, 0, 0. Now, addition of the two column directly. Minus 1 plus 1. Minus 1 plus 1, 0. 5 plus 0, 4, 9. So, is it right?
Yes.
7, 10, 14. One thing you can observe, these elements are 0, na? 0, 0, 0, 0. That's why that does not affect on the next one. So this is the first step. So again, your diagonal entry is this one.
Sir, there should be 17.
A44 is 17.
Yes, correct.
17.
Yes, I will correct. This is 17. Thank you. This is your diagonal entry. So after getting the elements below A11 and right side to A11 to 0, the same process you have to repeat for A22, A33, A44 till you are getting the normal form. So the next one is A22. So this element I have to reduce to 1. Tell me the process or the transformation. You are changing R2.
R2
First.
minus R3.
R2 minus R3. And one thing you remember, whatever 0 you obtain, that 0 must remain same up to the end. So likewise, you have to apply transform. Okay, Aditya says that R2 divided by 5, that also correct. But what I am suggesting, in the normal form, try to avoid the fraction. Try to avoid the fractions. Because of that, your calculations may be wrong. Okay, instead of that, I will apply R2 minus R3. If you are applying that divided by 5, you continue with your calculation. So this transformation shows that change for second row. First row, 1, 0, 0, 0. Second row, what you have to do? You have to have subtraction. 0 minus 0, 5 minus 4, 3 minus 9, 7 minus 10. Verify the calculation. 0, 4, 9, 10, 0, 9, 12, 17. This is a new matrix. Now, this is your diagonal entry. So after getting the element A22 as a 1, same repetition. You have to reduce the elements which are below to A22 to 0 by using this one. Can anyone guess what will be the transformation?
R3 minus 4R2.
Yeah, correct. And one more?
R4 minus 9R2.
Yeah, continue. So the transformation corresponding to this is a third row. This 4 present in the third row. That's why R3 minus 4R2. R2 is the key row or pivot row. You are using that row to reduce the element 0. And next one is R3 minus 9R2. Now the new equivalent matrix. Don't use equal sign again and again telling. So you are applying row transformation. That's why I represent the matrix row wise. Change in third and fourth row. This is fourth. This is fourth. Change in third and fourth. First two row, no change. 1, 0, 0, 0, 0, 1, -6, -3. Apply the transformation. Multiply this row by 4 and their subtraction. Can anyone tell the elements? 0, 0. If required, this one note can work as a calculator. Here I will write
33.
9 plus 24. Yeah. This is 33. Yes. 33. Similarly.
22.
22.
10 plus 12 equal to 22. So this is a next row. Similarly, by applying the next transformation, obviously the first two elements become 0. 12, you have to multiply by 9. You have to multiply it by 9.
66.
Okay, you continue. 66.
44.
44. Okay, hope so. You are doing correct calculations. Again, this is a diagonal entry. The same thing you have to continue. After getting the elements which are below to A22, this is A22. After getting the elements below to A22, you have to reduce the elements which are right side. The same thing you have to repeat. Reduce to 0 by using this column transformation. Yes, anyone?
C3 plus 6 C2.
Correct. C3 plus 6 C2, change for third column. Next one more. C4 plus
3 C2.
3C2.
3C2. Therefore, the new equivalent matrix. Therefore, I think visibility is clear now. Whatever I'm using, that font size, everything is fine now.
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
So the new equivalent matrix. Now here I am applying column transformation. That's why I will represent matrix column wise. 1, 0, 0, 0. Second also no change. 0, 1, 0, 0. Now tell me the resultant.
0.
Will be
33.
66,
66.
22, 44.
Okay, this is a new matrix. Now the same thing you have to continue. So after getting the elements which are below, yes, sorry, which are below to A22 and right side A22 0, come to this, and try to reduce this element as a 1. If you observe, if you notice the entry in the column, so here only I will perform two operations. So 1 upon 33 multiplied by C2, any non-zero scalar. In the same manner, again I will multiply.
C3, sir.
Yeah, C3, and this is C4, correct. Okay, simultaneously I will perform one more also because these are also multiple, na? So column transformation, that's why you have to represent the matrix column wise. First two columns, this I have to correct, this is a C3. This is a C3. So the next, first two columns, no change. 1, 0, 0, 0. 0, 1, 0, 0. So if you multiply 1 upon 33, then definitely you will get 0, 0, 1 and 2, right now? Similarly, 0, 0, 1 and 2. This is a new matrix. Now again, in the new matrix, this is your diagonal entry. The same thing you have to repeat. So you are getting this A33 element as a 1. Now you have to reduce the elements which are below to A33 to 0 by using this third row or this element. What is the transformation?
R4
2R3 minus R4.
2R3.
कोणतरी उलट सांगते बघा पहिला 2 नाही R4 minus 2R3.
R3.
Okay, उलट
R4
सांगा
minus 2.
2R3, only one transformation, that's why. So this is a row where row transformation you have to represent matrix row wise. Only change in the fourth row, first row. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1 and 1. And when you multiply that third row by 2, both row becomes identically same. So the resultant is 0, 0, 0. Okay. Again, whether this is in the normal form,
No, sir.
still one more element you
No.
have to reduce to 0. Okay, this is A33. And after getting the elements which are below to A33 to 0, you have to reduce the elements which are right side to A33 by using column. What is the transformation?
C4 minus
C4
C3.
minus C3.
C4 minus C3.
C3, yes. New equivalent matrix, column wise you have to represent. First column, no change, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. I think both are identically same. So the new resultant column is a 0. Now in this matrix, fix the diagonal entry. One thing you can observe orally, instead of mathematical definition, we can see in the reduced matrix or in the equivalent matrix, all the diagonal elements, even it is a rectangular, you have to treat A11, A22, A33 like that. That is a diagonal entry. All the diagonal elements are either 1 or 0. That is the first condition. And the second condition, non-diagonal elements are 0. That means this is the required normal form. Now this can be written as, you have to take the block now. You have to represent in terms of the block matrices. So further this can be written as, here I am using equal sign. Why? The same matrix I am representing. So here first block is a unit matrix of order 3. This is a 0 matrix, this is a 0 matrix, this is also 0 matrix. This is a normal form, this is a normal form. And what is the rank?
3.
Yeah.
3.
Therefore, rank of the matrix A is 3. That is the final required answer. I think any doubt, any questions?
No, sir.
No, sir.
After solving more examples, you will get a more idea to reduce the matrix to normal form very fast. Because one thing I want to explain here only, one thing you can observe here, I will use some different color. Okay. Now see, where is the matrix? Yeah, one more step, one more. So this is 5 plus 4 is 9, 3 plus 9 is 12, 10 plus 7 is 17. So here you can apply the transformation as, for your understanding only, R4 minus R2 plus R3, straight away you will get a fourth row as a 0. So when after solving more number of examples, you will get such type of idea. But generally follow the technique that A11 element, below to that, right side to that 0. A22 element, below to that, right side to 0. So you have to continue this process till you are getting to the normal form. Okay, and from that you can identify the rank. Okay, I will write the second example statement. Suppose the matrix is first row 3, 2, 1, 4. Second row -1, 3, 2, and 2. 2, 5, 3, 6. And the next one 5, 7, 4, and 10. So what is the order of the matrix? Again, you are having 4 by 4. Just a minute. Again, we are having 4 by 4. So the first step, call the given matrix as A. Let A is equal to the given matrix, first row, 3, 2, 1, 4, minus 1, 3, 2, 2, 2, 5, 3, 6, 5, 7, 4, and 10. Now I will not use a highlighter to denote that diagonal elements. So my first target is try to obtain, it is not a mandatory, this element as a 1. Tell me the transformation.
C4 minus
C1 minus C2.
Okay, you can operate C1 minus C2, or you can operate R1
C4
minus
minus
R3.
C1.
Yeah, you continue with your calculations. I will continue with C1 minus C2. Okay, you may consider R1 minus R3, or you can interchange multiplied by minus 1. So this one, suppose I will continue with the C1 minus C2. So the new matrix, column transformation, that's why I will represent matrix column wise. C1 minus C2, 3 minus 2, minus 1 minus 3, 2 minus 5, 5 minus 7. Verify the calculations. Now the remaining elements remain same. That is 2, 3, 5, 7, 1, 2, 3, 4, 4, 2, 6, 10. You may continue with your calculations, because this interchange is also possible. You can continue with your calculations. Okay. Now the next, tell me, after getting A1 one element as a 1, now you have to follow the standard process. You have to follow the standard process. So the same page I will use. This is a suppose. Okay. Here only I will solve in one page. Okay, fine. Now, this is your A1 one element. And our target is to reduce the elements which are below to A1 to 0 by using R1. Tell me the transformations.
R2 plus 4R1.
Yes, R2 plus 4R1, R3 plus
R3.
3R1, correct. One more, R4 plus
2R.
2R1.
2R1. So these transformation shows that change in R2, R3, and R4. Now you are applying elementary transformation row. That's why I represent the matrix row wise. First row, 1, 2, 1, 4 remain same. Now multiply by 4 and their addition. Obviously, first element becomes 0. 3 plus 8.
11.
Correct.
11, 6, 10.
Okay, fine. I will write directly. Verify the calculations. So next one, you have to multiply by 3 and addition. Obviously, the first one is 0. 5 plus 6, 11. 3 plus 3, 6. 6 plus, what is the next element? 6 plus,
18.
yeah, it's 18. So the next one, you have to multiply by 2. You have to multiply by 2 and addition. Obviously, this is a 0. 2 plus 4. 4 plus 2. 10 plus 8. Check this 10. 10 is correct now, this one? R2.
Sir, it's 18.
It's
Yes, it's 18. Because what is your transformation? 2 plus 16, that is 18. Check the calculations. Okay. So again, after getting the elements which are below 2, A11 to 0, this is A11. Next, you have to reduce the elements which are right side, these elements to 0 by using column transformation. Yes.
C2 minus 2C1, C3 minus C1, and C4 minus 4C1.
C3 minus C1 and C4 minus 4C1. So the new equivalent matrix. Column wise you have to represent. First column 1, 0, 0, 0. Obviously, when you are applying such type of transformation, only the rounded by blue color, that becomes 0. 11, 11, 11, 0, 6, 6, 6, 0, 18, 18, 18. Okay. So after that, go through the process only. This element you have to reduce to 0. What is the transformation?
R2 minus R3.
Now see, one thing you can observe. In the second column, all the elements are 11, na? In the second column, I think that is not visible. See this part. All the elements
C2
are...
divided by 11.
Yes. Similarly, C3 divided by 6. C4 divided by 18. So here, 1 upon 11 multiplied by C2. 1 upon 6 multiplied by C3. 1 upon 18 multiplied by C4. So the new matrix, column transformation again, 1, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. Here only you can guess the rank. What is the rank? Okay, continue. This is
3.
where-
Sir, 3.
No.
3.
Okay, continue the calculation. We'll see. After that, come to A22. Now the next process, the elements which are below to A22, these elements you have to reduce to 0. Now simple calculations by
R3 minus R2.
R3 minus R2.
R4 minus R2.
R2. That is a key element that you have to remember. Huh? Yeah, little bit I will take up. Then new equivalent matrix. So row transformation, that's why I will represent the matrix row wise. 1, 0, 0, 0. Because change in the third and fourth row. Second row, no change. 0, 1, 0, 0. If you look at the rows, they are identically same. That's why when you take subtraction, you will get a row with all elements 0. Correct, na?
So
Row,
second row,
something
0,
I did.
1, 1, 1.
Yes, this one is 1, 1. I will rub that. I am in a hurry to calculate. Okay, this one. Second row, no change, na? Yes. So again, this is your diagonal entry. The elements, after getting the elements below to A22 0, you have to reduce the elements which are right side to A22 0 by using this one. Tell me.
Sir, rank is 2.
Yeah, rank is 2.
Rank 2.
That's why I'm asking here only. Na? You can, after by solving some more examples, you will get idea. Here, C3 minus C1. Sorry, C2. C2 is the key element. C4 minus C2. So the new equivalent matrix. You have to reduce or you have to complete the calculations. Huh? Column transformation, that's why I will represent the matrix column wise. 1, 0, 0, 0. Second column also no change. 0, 1, 0, 0. Now, these two row columns are identically same, and when you take a subtraction, 0 minus 0, 1 minus 1, 0 minus 0, 0 minus 0. Similarly, 0 minus 0, 1 minus 1, 0 minus 0, 0 minus 0. Now, in the new matrix, fix the diagonal entry. All the diagonal elements are either 1 or 0. All the diagonal elements are either 1 or 0. That first condition satisfied. And the remaining non-diagonal elements are 0. So here I will write, so the first block, I think my cursor is not active. Instead of that, I will use some color. So this is the first block. This is a unit matrix for this. For this, I will write as a unit matrix of order 2. Similarly, next one. Suppose this one, this is a 0 matrix, whatever the order is not important. So that's why for that I will write 0. This also 0 means for what? I will use same color. That means you can understand. For that I am writing this one and this I2 for the same thing, I2. And suppose the next one, this is a 0 matrix. For this, here I will write 0. Here I will write a 0 matrix. This is a capital O. And further for this again, this is also 0 matrix. So here I will write that is a 0 matrix. So again, you are having a block like this. So what is the rank?
2.
Rank of A is equal to 2. Right. Rank of A is equal to 2. That is the answer. Okay, any doubt? If any questions are there, you can ask meanwhile. Or shall I continue the next or any questions? Okay. Silent means no questions. I will continue with one more example. That is 1, 2, 3, fourth. Fourth example. Suppose the matrix 2, -4, 3, 1 and 0, 5 columns. 1, -2, 1, -4 and 2. 0, 1, -1, 3, 1, 4, -7, 4, -4 and 5. Okay, so continue with the calculations, or you can help me simultaneously. Suppose first step, in the regular manner, I will call the given matrix as A. Let A is equal to first row 2, -4, 3, 1 and 0. Second one 1, -2, 1, -4 and 2. 0, 1, -1, 0, -1 and 3, 1, 4, -7, 4, -4 and 5. Okay, so tell me the first one. I think the procedure is clear. Yes, what?
R1 minus R2.
Okay, you can continue with R1 minus R2, or I will interchange R1 and R2.
C1 and C4.
No, I will interchange R1 and R2. That also possible, no?
Yes, sir.
I will interchange R1 and R2. Continue with the calculations. Yeah. Then the new equivalent matrix. Little bit, I think it's fine. The new equivalent matrix, which is given by second row becomes first. That is 1, -2, 1, -4 and 2. And first becomes second. That is 2, -4, 3, 1, 0. Remaining rows as it is 0, 1, -1, 3, 1, 4, -7, 4, -4 and 5. Okay. Now, in this case, the diagonal entry is, because this is a rectangular matrix, A11, A22, A33, A44. This is a diagonal entry. So you are getting A11 element as a 1. So next you have to reduce the elements which are below to A11 to 0 by using row transformation, R1. Let me know the transformation by
R2 minus 2 R1.
R2 minus 2R1, R4 minus 4R1.
R4 minus 4R1. Already for R3, no change because having 0. So the new equivalent matrix where change in second and fourth row, first row, 1, minus 2, 1, minus 4, and 2. Okay. So what you have to do? You have to multiply by 2. You have to multiply by 2 and their subtraction. 2 minus 2, 0. I think minus 4 and minus 4, correct? Huh? Their subtraction. 3 minus 2. 4 minus minus plus 8. 0 minus 4. Verify the calculations. Third row remains same. 0, 1, minus 1, 3, 1. Now next you have to multiply by 4. You have to multiply by 4 and their subtraction. Can anyone tell the elements?
One.
Okay.
Zero.
0.
Correct. अरे संपत आला आता कोण ऍडमिट करायला म्हणते
Zero.
0 4 minus 16 ना this is minus
Minus 12.
Plus 12.
12, 12.
5 minus 8. Okay.
minus 3.
Yeah. Again, this is your diagonal entry. Now, after getting the elements which are below to A11 to 0, you have to reduce the elements which are right side, these elements. So the transformations are Sanga C2 plus 2C1, C3 minus C1,
C1.
C4 plus
Plus
4C1.
C5 minus 2C1. So the new equivalent matrix, column wise, first column no change, 1, 0, 0, 0. Second one, 0, 0, 1, 1. Next, 0, 1, minus 1, 0, 0, 9, 3, 12, 0, minus 4, 1, and minus 3. Yeah. So this is the diagonal entry. So what is your next step? Can anyone guess?
Sir, rank is 1.
I don't have answer. I have to continue with calculations. Can you tell suggestion what I have to do here? Because our next target is this element to reduce.
C2 plus C3.
Yes, C2.
Plus C3.
थोडं कोण अथर्व ठीक आहे C2 plus C3 is also okay. Instead of that, I will try to shift this one to here by interchanging the rows, or I will try to shift this one to here by interchanging the rows. Anyone can. So here I will apply your calculations or your transformation is also correct, huh? But you have to use simple. So I will interchange second and third. Just a minute, huh? Cursor is not working. Yeah. What happened? 1 minute. Yeah. Interchange C2 and C3, not 2, 2. C2 and C3. Who told the answer as a 1? 1 shakyatu yenar nahi. You may did some mistakes by applying the transformation. Let us check. So the new equivalent matrix where first row no change, 1, 0, 0, 0, 0. Third becomes second, that is 0, 1, minus 1, 3, and 1. Second becomes third, 0, 0, 1, 9, and minus 4. So the last one remains same, 0, 1, 0, 12, and minus 3. So again, this is your diagonal entry. Now you obtain A22 element as a 1. So you have to reduce the elements which are below to A22 0. Suggest the transformation.
R4 minus R2.
R4 minus R2. So the new equivalent matrix, change for fourth row only. First three rows, no change. 1, 0, 0, 0, 0, 0, 1, minus 1, 3, 1. Third also no change. 0, 0, 1, 9, minus 4, 0, 1 minus 1, 0, 0 minus 1. That's 1. 12 minus 3.
9.
Minus 3 minus 1.
Minus 4.
Okay. Now again, this is your diagonal entry. After getting the elements below to A2 to 0, so the next step, right side, these elements by using column. Yes, by C3 plus C2, correct? C4, minus 3 times C2 and C5 minus C2. Make me correct if I am writing the wrong calculations. Change for third column, fourth column, and fifth column. So first two column, no change. 1, 0, 0, 0. Second column, 0, 1, 0, 0, 0, 0, 1, 1. Correct, na? 0, 0, 9, 9. 0, 0, minus 4, minus 4. Can you guess what will be the rank here?
3.
Yeah, 3. तुम्ही असं म्हणाल की हा दोन्ही एकमेकाला घालून टाका असं नाही. Don't apply such type of transformation. C2 minus C1 and C1 minus C2 simultaneously. No. So that's why I'm telling you have to use the key element concept. Which element you are using? Okay. Now continue. So after getting the elements which are below A1, below A22 and right side to A22, come to A33. Now the next same process. Reduce the elements which is below to that A33 to 0 by using third row. What is the transformation?
R4 minus R3.
R4 minus R3. Change for fourth row only. First three rows, no change. That is 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 9, 4. Now you can observe both rows are identically same. So you will get that row as identically 0. So again, this is your diagonal entry. After getting the elements which below to A33 to 0, now the elements which are right side to A33 by using column transformation. Yes?
C4 minus 9 C3.
C4 minus 9 times C3, you have to use third column. C5 minus 4 times C3. So the new equivalent matrix where change in the third, change in fourth and fifth column. Observe this. Okay. So the elements, first three columns, no change. 1, 0, 0, 0, 0, 1, 0, 0. C3 also no change, na? 0, 0, 1, 0. What will be the result at here? Correct, na? Now in this matrix, the diagonal elements are either 1 or 0 and non-diagonal elements are 0. So further it can be classified or blocked as, so this can be written as, okay, I will little bit, I will scroll up. It's fine now? Yeah. So in this case, I'm using equal, last step, I'm using equal. And this is denoted as unit matrix of order 3. This is 0 matrix, 0 matrix, 0 matrix. So the blocks are like this. Therefore, what is the rank?
3.
Yeah.
3.
Therefore, rank of A is 3. That is your final answer.